Hi, everyone. The Netherlands is a country where 1/3 of its territory is below sea level. And 2/3 is an area prone to flooding, but thanks to its sophisticated anti-flood mega project, the Netherlands has so far been able to survive the flood disasters, which have often hit it in the past. So how is the history of this anti-flood mega project in the Netherlands made, and what structures are included in the anti-flood mega project? The following is the Mega Flood Project, the largest and most expensive in the Netherlands. Initially, the Dutch were able to overcome floods with a polder system and windmills since the 15th century. That's why the Netherlands is called the country of windmills, and until now it has become an icon of that country. A polder system is a system that incorporates dikes, lakes, and pumps. How it works: if the sea level rises, it will be overcome with an embankment wall, just by raising the embankment wall to be able to protect an area, whereas in windmills, by utilizing wind power, windmills pump water out of swamps, and create folders or patches of dry land, and turn them into irrigated agricultural land. In addition, the windmills also pump water in the lowlands to prevent plants from drowning in floods. But in 1953 came a major flood due to the brunt of seawater from the north, breaking through the flood-resistant walls or embankments until the floods entered the city. The flood claimed 8,361 lives, destroyed 10,000 buildings, and inundated 9% of agricultural land in the Netherlands. So that a similar disaster does not happen again, 20 days after the big flood hit the Netherlands, they made a mega anti-flood project, namely Delta Work. In February 1953, the Department of Delta Committee was established to develop a plan to protect the area from future flooding and also provide clean drinking water, which is called the Delta Plan. In the Delta Plain, the coastline was reduced and shortened to about 710 meters. This reduction automatically affects the length of the embankment, which is also reduced, so that it can help drain low areas that often flood, and regulate the flow of salt water from the sea, as well as provide fresh and drinking water for irrigation. In addition, the Delta Plan also increases inter-island traffic movements, and increases logistics delivery, especially between Rotterdam and Antwerpen. The Delta Plain project consists of 13 dam constructions, including storm barriers, sluice gates, locks and levees to protect areas of the Netherlands from North Sea flooding. This Delta Work project was carried out by the Water and Public Works Service, which was finally completed in 1627 at a cost of around $15 billion. Besides that, this project also reduces the risk of flooding within 4,000 years. Even the Delta Plan project is also recognized as one of the 7 wonders of the modern world by the American Society of Civil Engineering. From 1953 to 1997, the Delta Plan project has now built many dams, dikes, sluice gates, and storm barriers. Among these structures, there are 2 of the largest storm barrier structures ever built, namely the Oosterscheldekering and Maaslandkering. Oosterscheldekering, or what is called the storm surge barrier, is designed to close the Esterschelde River in the east, which functions to create water salinity, so it doesn't disturb the ecosystem inside. Oosterscheldekering is a dam with a gate that can be opened and closed during storm surges and high tides. Construction of the Oosterscheldekering started in 1976 at a cost of €2.5 billion. The Oosterscheldekering has a length of 9 kilometers, consisting of 62 steel doors, with a width of 42 meters each. Because of these very large dimensions, the construction of the Oosterscheldekering requires sophisticated technology and careful planning. In the process of building the storm barrier, through several stages, namely making the foundation first. To make the foundation needed 2 artificial islands, in which there is a pier that serves as a place for making 65 pylons, or a very large tikal structure that has a sluice. Each of these pylons is made of 7,000 cubic meters of concrete, which has a hole in the inside and took a year and a half to build. Between the two artificial islands is then dug to make a trench to a predetermined depth. And this trench will later be made into the foundation for the pylons earlier. Then on top of the parrot is given a layer of mud, which is made of flexible material and is given rocks that function to prevent erosion under mud. The finished pylon is then transported using a special ship called Austria, which can carry loads of up to 10,000 tons. The pylon is then brought to a predetermined location, then lowered onto the mud. Then the pylon will be filled with sand and covered with concrete. After that, at the bottom of the pylon, rocks are placed, so that the pylon cannot move and stays in place forever. Finally, a giant hydraulic is connected to the sluice gate on this pylon, which functions to open and close, which is controlled by the operator. For hydraulics, it can lift loads of 260 to 480 tons, and can lift loads between 6 and 12 meters high. While each of these pylons is 35 to 39 meters high, and weighs a total of around 18,000 tons, designed to last more than 200 years. Apart from being a barrier to the Oosterscheldekering wave, it also functions as a highway that connects traffic between islands. Then the next structure is Maeslantkering. Maeslantkering, this is a storm barrier built from 1991 to 1997, which is also part of the Datawork mega project. This storm barrier consists of two giant gates, which function to hold seawater with the length of each door equivalent to the height of the Eiffel Tower. And the weight is almost 4 times that of the Eiffel Tower. 2 doors. This giant consists of steel segments that have a length of each segment 210 meters and 22 meters high. These 2 doors can move as far as 237 meters with a sideways swinging motion. During normal conditions, the dry door will open 360 meters wide, so that ships can pass, and the door will automatically close when you feel storm waves and seawater, which is about 3 meters high. Maeslantkering can withstand storm waves with a force of 350 megaton, or the equivalent of 350,000 strong people, each lifting 100 kilograms of weight. Since it opened in May 1997, Maeslantkering has only closed twice, in order to prevent seawater from overflowing due to the devastating North Sea storms, namely in November 2007 and early 2018. And the closing process of the Maeslantkering gate takes about an hour, and this Maeslantkering can last for 80 years.